Now let's look at project crashing. So project crashing, remember, is time reduction. So when you have activities that can be completed faster than normal by spending more money, okay, then that process is called crashing. Is it beneficial to spend money on some activities, thus reduce the project completion time? Is there savings that will allow us to do that? Okay, so that's the idea. So and this is the approach. This kind of modeling is called CPM modeling, critical path method modeling. So here you will have, remember, this is for projects where activity times are deterministic. The activities are so well understood that you can not only precisely estimate how long it will take under normal conditions and how much it will cost, but also by spending what amount of money you will be able to complete that activity by how much faster. So all of that information is readily available to us. So we have four pieces of information for each activity. So we have the normal time and normal cost. And then what is the crash time and crash cost? Crash time is the shortest possible time the activity can be completed, and how much will it cost for that amount of time. Okay. So once you have that, then we can compute crash cost per time period by looking at the difference in the cost dividing by the difference in the time. So that will give you cost per time period. Okay. So now we're going to assume, okay, let's skip over here. Okay, this one. So we're going to assume the linearity of cost. Okay, so this is the normal time and normal cost, right? So it takes 3 weeks and it costs $30,000. But crash time, which is the shortest possible time in which the activity can be completed, is 1 week, but it's going to cost you $34,000. Okay. So now we're going to assume, for the purpose of our analysis, that any amount of crashing between these 2 points is possible and the cost will be proportional. So which means you can crash to from 3 weeks down to 2 weeks, in which case it'll be exactly in the midpoint will be the cost. Or you can crash it down to 3/4 of the way, or a quarter of the way down, then the cost will be quarter of the way. So which means here 34,000 minus 30,000 divided by 3 minus 1 is $2,000 a week. So if you crash by half a week, it's going to cost you $1,000. If you're going to crash by 1/10 of a week, it's going to cost you $200, and so on. Of course, how much crashing you can do is between these two, normal and crash time. So the maximum crashing allowed is 2 weeks. 3 minus 1, 2 weeks, and any fraction of 2 weeks you can crash, and the cost will be proportional. So that's the assumption that we're making for the purpose of our modeling, which need not be true. So either you either do the normal time, or if you have to crash, you have to crash it all the way down to the crash time, and nothing in between is possible. Could be true in some cases, but we are going to assume that that's not the case here. All right. So let's look at the costs and see where we are. So we have activities, okay, and then we have 4 pieces of information: normal time and crash time, normal cost, and crash cost. Okay. So once we have that, then we can compute maximum crashing allowed. So I'm using this terminology here, MCA, to stand for maximum crashing allowed. So how much is the maximum allowed? So normal time minus crash time will give you the maximum crashing that is possible. Okay. Sometimes some activities you may not be able to crash at all. So normal time and crash time are the same, in which case MCA will be 0. Okay. Now what is the difference in the cost? So that is crash cost minus normal cost. So now if you divide that by the maximum crashing allowed. All right, so that will give you crashing cost per week. Okay. All right. So now, which activity will you crash then? All right. So crashing cost per week. So you see, the smallest cost for crashing is for activity F. So is that the activity you will crash? No, you have to maybe, but we have to see whether crashing F will actually result in reduction in the project completion time. Remember, project completion time is given by the critical path. Now, if F is in the critical path, then crashing F will reduce the project completion time, and that will be a good activity to crash. But if F is not in the critical path, then crashing F will not affect the critical path. The critical path would still be whatever it is, 15 weeks or whatever. So crashing F, so spending $500 a week and crashing F is not going to make any difference at all. So why you will not crash? Yeah. So to determine which activity to crash first, you have to look at the critical path. So remember, we've already done that. Critical path is that. So let's copy paste that over here. Okay, so A, C, E, G, H. A, C, E, G, H. So these are the, okay, I'm going to highlight that with something. So these are the critical activities. So we have to look at the least cost activity of the critical activities along the critical path. So here there are 3 activities with $1,000. That's the cheapest cost, and there are 3 activities. So you can select any one of these 3 to crash. Okay. But when you start crashing, what will happen is, okay, so remember when we started out, we saw that there are 3 paths, right? So now if you select activity A to crash, and you keep crashing, so if you crash A by a week, so here remember, so A is one of the activities. So it's like if you crash E, you can crash by 2 weeks. But if you crash E by 2 weeks, what will happen? The first week you will reduce the project completion time from 15 to 14. But the second week when you crash, this path will go from 14 down to 13. But this will become critical, and the project completion time will not change from 14. So the first week there will be an effect. The second week there will not be any effect at all. The project completion time will not go down beyond 14. So it becomes really messy to do this manually by looking at all the different paths. So it is very essential that we have a model that will help us come up with the best way to crash. So that's what we're going to set up a non-linear model and a linear model to determine the best activities to crash so that we can get to the minimum project completion time.